All right, for this problem that we have here is going to be balancing chemical equations. And you may know another way to do this. I actually discovered this myself a few years ago in a different textbook, and I really like it because it's a very efficient way of doing it. So the way that I had learned, and the way you may have learned, was to just keep fiddling with these coefficients out front here using integers to balance. And so just keep making changes until everything comes into balance. So like maybe you would put a 2 here to get iron into balance. And then, oh, well, now I've got 6 sulfurs and 8 here, so that's not going to work. And I just keep adjusting. And so it's like trying to get something into balance, and it just keeps coming out of balance. And it takes, it could take 20 or 30 steps to do in that way. This is a really efficient way. And it's got a couple rules to follow, and that's it. First is you look for whatever the most complex species is, and that's the one that has the most types of elements and most number of atoms, with the most types of element being the more important rule. So this has iron and sulfur in it, so this is going to be the most complex species. And I'm going to put a 1 up here and circle it just to remind myself and remind you this is what I touched first. This is the one that I sat down and wrote first. So now that I've staked this down to say that I'm going to, for the moment, have 2 irons and 3 sulfurs, I can go over and balance my irons, and that's easy. And then sulfurs, well, this method also uses fractions. And it uses fractions in the middle, and then we get rid of those fractions near the end. So I'm going to do 3/8 here. And so 3 times the 8 sulfurs, that's 24 sulfurs. 24 divided by 8 gives me the 3 that I need. Okay, so this is perfectly balanced now, but it's not balanced with integers. So it's balanced, but it's not balanced to the way that we would want it to be to use it. And so I'm going to do times 8 here, and that will clear out the fraction that's there, and that will be my 4th step. So 8 times 2 gives me 16 irons. 3/8 times 8 gives me 3 S8s. And then finally 8 times 1 gives me 8 Fe2 S3s. And we can verify that this is balanced in the way that you may have been taught before. 16 irons, 8 times 2, 16 irons. 3 times 8, 24 sulfurs. 8 times 3, 24 sulfurs. So it is balanced once we've done this process. Here's a little bit more complicated one. Actually, I could pick based on my rules. This has 2 elements, this has 2 elements, this has 2 elements, and this has 2 elements. Both of these have 3 atoms in them, so I could actually pick either one of these. I'm just going to pick one. It would work the same if I had picked H2S. I'll pick this. Well, now that I've staked my claim, I know that I have 1 zinc. So I just am focusing on zinc at the moment, and I have 1 zinc because I've already staked my claim to 1 zinc. I've also staked my claim to 2 chlorides, and so I got 2 chlorides there. And then finally, it looks like this other part worked out for me. 1 sulfur, 2 chlorides, and 2 hydrogens and 2 hydrogens, 1 sulfur. So I'm just going to put a 1 there to know that I've done that. And then this is actually perfectly balanced, and I don't have to do anything to clear it. So zinc, there's 1 zinc, and then over here there's 1 zinc. There's 2 chlorides, and then there's 2 chlorides. There is 2 hydrogens, and there's 2 hydrogens. There's 1 sulfur and 1 sulfur, so that is absolutely perfectly balanced. All right, now this one is a beast to do the normal way because you've got oxygen in all 3 species. So anytime you tinker with one, it messes the oxygen count up again. And then you've got all your hydrogen here, all your phosphorus here, and then this has hydrogen and phosphorus. So anything you move makes something else move, and it's just a disaster. This is the most complex species. It has 3 different types of elements, so I'm going to give it the 1. That's my first step. I am going to balance, let's balance hydrogens. I have 2, I need 3, so I'm going to have to use a fraction again, 3 over 2. And that's my second step. That will give me 3 hydrogens. 3 times 2 is 6, divided by 2 gives me the 3 that I need. And then finally, let's do phosphorus. I need 1 phosphorus, and I have 4, so I'm going to do 1/4. Now I got to clear all this out, though. It is totally balanced, but it is not the way that we would want it with integers. And so I got 2 different fractions to clear here. I'm going to go ahead and multiply by the bigger one and just hope things work out. So I'm going to go times 4, and that's my 4th step that I'm doing. So 4 times a 4th is 1 P4O10 plus 4 times 3 is 12. 12 divided by 2 is 6 waters. And then 4 times 1 gives me 4 H3 PO4s. All right, let's check this beast now and see if it is balanced or not. So 4 phosphorus and 4 phosphorus, 10 oxygens, and then 6 more, so 16 oxygens. And then 4 times 4 is also 16 oxygens. And then finally hydrogen. 6 times 2 is 12 hydrogens, and 4 times 3 is 12 hydrogens. So this is also perfectly balanced.